Assalamu alaikum friends, today we are going to study hydrocarbons. All the organic compounds are known to contain carbon as an essential element. This fact has led to us to define organic chemistry as the chemistry of carbon compounds. The ionic compounds like carbonates, cyanates, carbides and cyanates etc. are the oxides of carbon and however classified as inorganic compounds. Apart from carbon, most of the organic compounds contain hydrogen and oxygen as well. Organic compounds are famous for their large number and diverse behaviors. Several million organic compounds are known to exist naturally or have been synthesized in the laboratory. Organic molecules are usually large and more complex in nature. They include biomolecules like proteins, enzymes, carbohydrates, lipids, vitamins, and nucleic acids, pharmaceutical and synthetic fibers, etc. The number of compounds formed by the element carbon is far more than the total number of compounds formed by all the rest of the elements put together. This is due to some unique properties of carbon. The element carbon is present at the center of the periodic table and it is generally not possible for it to gain or lose electrons to form ionic bonds. Therefore, it forms 4 covalent bonds. Because of its small size, these covalent bonds are short and strong, enabling carbon to give strong and stable bond with itself and with hydrogen, oxygen and nitrogen. The self-linking property of an carbon is called catenation and is due to this form long, straight and branched chains and rings. Carbon atom mostly form covalent bonds with other carbon, hydrogen, oxygen, nitrogen and halogens. Compounds in which carbon forms single bond with other atoms are saturated compounds. These compounds are generally represented by their structural formulas. Methane, a saturated compound, is represented by the following structure formula. A structure formula thus shows the symbols for the atoms present in the compounds connected by short lines which represent the bonds present in them. Other examples of saturated compounds are C2H6, CH3HCl, CH3OH, CH3NH2, etc. Hydrocarbons. The family of hydrocarbons constitutes a very large number of simple organic compounds containing carbon and hydrogen only. Most of the fuels in which we use every day, for example natural gas, LPG, compressed natural gas, CNG, petrol, diesel and kerosene oil, all are examples of hydrocarbons. These hydrocarbons also serve a feedback as a feedstock to prepare more complex and useful compounds like plastics, medicines, synthetic fibers, paints and varnishes. Hydrocarbons are classified into several structures types called alkanes, alkynes, and aromatic hydrocarbons. Only alkynes are discussed in this chapter. Methane is the simplest alkane and it is mainly used as a fuel but is also used to make hydrogen gas. Carbon black, carbon disulfide, chloroform and hydrocyanic acid. Alkanes are the simplest family of hydrocarbons with only carbon and carbon hydrogen single bond. Alkynes are all called saturated hydrocarbons because all the 4 valencies of carbon in them are fully utilized either by hydrogen atoms or by other carbon atoms. For example, in ethane, both the carbon atoms are fully saturated with single bonds. Alkanes are represented by general formula CnH2n plus 2, where n is an integer. Methane, being the simplest hydrocarbon, is also called a parent hydrocarbon. As a result of the great complexity and large number of organic compounds, it is not possible to name each and every compound individually. The International Union of Pure and Applied Chemistry has devised a systematic way of naming organic compounds are called IUPAC Nomenclature. According to IUPAC system of nomenclature, the entire name of an organic compound has 3 parts. Root, it tells us the number of carbon atoms in the longest continuous chain present in the molecule. The root up to 10 carbon atoms are shown. Suffix, it is added after the root and tells us about the class of organic compounds. Prefix, it is indicated before the roots and tells us about the group or groups attached to the longest chains. To explain the above system, let us name the following compounds. Identify the longest continuous chain present in the compound. Identify the class of organic compounds. Identify the substituent or substituents if present. This organic compound contains 4 carbon atoms in the longest continuous chain and it belongs to family of organic compounds called alkane. The root is therefore but and the suffix and ane added to this. The organic compound will thus be given the name butane. The name of only branch methyl will be added to this name as prefix. To specify where the branch occurred, the longest continuous chain is numbered starting from the end closest to the branch. This number is then attached to this prefix. If butane has no branch, it is called normal or N-butane. Preparation of alkanes. Generally, any member of the alkane series can be prepared by the following method. Cracking of higher hydrocarbons. Cracking is the name of a process in which hydrocarbons with higher molecular mass, which are lesser in demand, are broken up into smaller hydrocarbons which are more in demand. This is done by heating the hydrocarbons at high temperature in the presence of a catalyst. Fractional distillation of petroleum gives naphtha, which consists of a mixture of liquid hydrocarbons. It is then heated at around 500 degrees centigrade in the presence of catalyst called zeolite to give hydrocarbons which have 5 to 10 carbon atoms. Cracking of hydrocarbons help balance the availability of petroleum fractions with the demand for them. When cracking transforms bigger hydrocarbons into small hydrocarbons, the fuel supply is increased. That helps to balance demand with supply. Reduction of alkanes and alkynes. Alkanes can be prepared by reducing alkenes and alkynes with hydrogen gas in the presence of nickel metal as a catalyst. Methane cannot be prepared by this method. The reaction is also called hydrogenation of alkynes and alkynes and is an example of addition reaction. An addition reaction occurs when hydrogen H2 is added to an unsaturated compound. Addition of hydrogen to alkynes or alkanes is called reduction reaction. This reaction is used to prepare banaspati ghee and margarine. Alkyl halides RX can be used to alkanes with nascent hydrogen generated by reaction of zinc metal with hydrochloric acid. Important reactions. Alkanes are sometimes referred to as paraffins, which means little affinity. This term describes the behavior for alkanes which show little chemical affinity for other substances and are chemically inert to most laboratory reagents. However, alkanes do react with chlorine and oxygen under suitable conditions. The unreactivity of alkanes may be explained on the basis of the non-polarity of the bonds present in them. The electronegativity values of carbon 2.6 and hydrogen 2.1 do not differ appreciably, and the bonding electrons between CH and CC bonds are almost equally shared. This fact makes alkane most non-polar. In view of this, the reagents like acids, bases, oxidizing agents find no reaction site in alkane molecules to which they could be attached. Halogenation. Alkanes give substitution reaction. The reaction which involves the replacement of hydrogen of alkanes by an atom or a group of atoms like halogen are called substitution reactions. Alkanes react with halogens, especially chlorine, to give alkyl halides. Since these substitution reactions are carried out in the presence of UV light, these are called photochemical substitution reactions. The reaction may be proceed ahead, and all the hydrogen atoms attached with carbon of the methane are successfully replaced by chlorine atom. Structure formula of the products. Combustion. Alkanes burst in the oxygen or air to form CO2 and H2O with the evolution of large amount of heat. The reaction is called combustion. The compounds obtained from plants and animals were named as organic compounds. Organic chemistry. Organic chemistry is the chemistry of carbon compounds. The element of carbon is unique in its behavior. Organic compounds are covalent in nature. Their melting point and boiling points are generally low. Organic compounds containing carbon and hydrogen are called hydrocarbons. They are classified into saturated and unsaturated hydrocarbons. Hydrocarbons containing a single bond between carbon and hydrogen are called saturated hydrocarbons or alkanes. Alkanes can be named by a systematic way of nomenclature called IUPAC system of nomenclature. Alkanes can be prepared by a number of different methods of preparation. Although alkanes show least reactivity towards their other compounds, they react with halogens and undergo combustion reactions. In the reduction of alkyl halides with ZnHCl, alkyl halide is being reduced, which specifies in this reaction which species in this reaction is being oxidized. During the combustion of reaction of ethane, which bonds are being broken and being formed, what products are other than CH3Cl are found between when methane reacts with chlorine gas. Empirical data collection and analysis. Introduction. Science is a systematic study of this world through with observation and experimentation. It is a method through which we make sense of this world in which we live. Scientific research is done in all the countries of the world, but the way it is done is not identical everywhere. In order to make sure things are done properly and carefully, we need to share ideas and standardize our approach towards solving the problem. One of the most usual problems which is faced by the scientific community is the issue of units. If scientists in one country are measuring lengths in meters and then another country in feet, then we have to face problems in converting them. Comparing quantities in different units is not only confusing but the wastage of time as well. For the reasons mentioned above, scientists have agreed to adopt standard and user-friendly units called SI or System International Units. Things become a lot easier when we use these units. The adoption of SI units is important in all branches of science because it makes communication easy worldwide. It also allows scientists to share data easily. SI units are preferred because they reduce the number of conversions needed to coordinate information among the systems. SI units use base 10 just like our number system, so it is much easier to learn, remember and convert these units. These units are based on definite and precious standards. SI units are interrelated in such a way that one unit is derived from other units without conversion factors. SI units are used almost everywhere in the world. It allows scientists to use a single standard in exchanging scientific data. This fact brings accuracy, consistency, and universal standing in scientific communication. A measurement taken in one part of the world can be easily understood and verified in another part without any confusion. When scientists belonging to different countries and cultures collaborate on research, they need a common language to share their results. Using SI units enables scientists to compare results, replicate experiments, and take benefit of each other work. In conclusion, we can say that SI units allow scientists to work together effectively, advancing the frontiers of our knowledge. All of this ensures safety, reliability, and reproducibility and progress. SI units in chemistry, there are 7 base units in the SI system for physical quantities, out of which we use 5 in chemistry. These physical quantities are length, time, amount of substance, mass, and temperature. Meter, it is the standard unit of length. Symbol M is used for meter. Meter is the distance traveled by light in vacuum in about 300 millionth of a second. Kilogram, its symbol is kg and it is the standard unit of mass. A block is kept in France which is taken as a standard unit of mass. It is also defined as the mass of 1000 centimeter cube of water. Second, it is the standard unit of time with a symbol S. It is the time that elapses during 9192631,770 cycles of the radiation produced by the transition between two levels of the cesium-133 atom. Kelvin, it is represented by K and it is the standard unit of temperature. It is 1/273 of the thermodynamic temperature of the triple point of water. It is a point at which all the states of water exist at the same. Mole, it is the base unit of the amount of pure substance and is denoted by MOL. It is defined as having exactly 6.02 multiplied by 10 raised to power 23 particles of a substance. Derived units, apart from these base units, there are other quantities that are mathematically derived from these base units. Example of derived units used in chemistry are given. Quantity, volume, cubic meter. Density, kilogram per cubic meter. Area, square meter. In addition to derived units, there are other specific quantities commonly used in chemistry table. Force, Newton, pressure, Pascal, energy, joule. In science, the SI system of the unit is a metric system. It is based around the number 10 or for convenience. A set of prefixes has been developed which indicates whether the unit is a multiple of or a fraction of the base 10. It allows the reduction of zeros of a very small number or a very large number. These SI prefixes also have a set of symbols that precede the unit symbol. In chemistry, we measure the masses of the reactants in grams. It is essential because the units of measurement of molar mass consist of grams per mole. Therefore, given a mass measured in grams as well as corresponding molar mass enables us to find the mole of a substance. Moreover, in chemistry, the quantities involved in the laboratory are likely to be small. The choice of gram rather than kg is therefore sensible and normal. Using grams provides more manageable numbers for calculation and prevents the need for excessively large or smaller values. Similarly, Celsius scale is most often used to measure temperature in chemistry rather than Kelvin because it is more convenient to use. Celsius scale has 100 divisions in total, which makes it more compatible with the base 10 format of SI system. Another reason is that it is easier to convert temperature on Celsius scale into Kelvin scale. The following equation is used for this conversion. Kelvin is equal to degree centigrade plus 273. And the unit of measurement of volume in chemistry is cubic meter instead of cubic meter because it is easily to measure and calculate with it, and it is precious. In laboratory, we usually measure smaller volumes of liquid which are more manageable in cubic centimeter rather than cubic meter. Measurement is the foundation for all experiments in science. Every measurement carries a level of uncertainty which is known as error. Error may be defined as the difference between the measured value of the actual value. For example, if two students use the same tool or instrument for measurement, it is not necessary that both of them get similar result. The difference between the measurements is called an error. An error may occur due to the two factors: the limitation of the measuring instrument and the skill of the student making the measurement.